Good morning, children. Today we are going to learn operation on real numbers. You know, rational numbers and irrational numbers are together known as real numbers. So, when we add, subtract, multiply or divide when you are dividing, you have to accept 0 because the division by 0 is not defined. When we add, subtract, multiply or divide two rational numbers, we get a rational number. That means you need to 1 by 2 plus 2 by 3. Then same way any two rational number you take, you do all these operations, you get another rational number. Now the next one you take the sum, difference, quotient and product of irrational numbers. Are not always irrational. So if you take 2 root 3 plus root 3, so you are getting 3 root 3. This is an irrational number. But when you take root 6 plus root 6 plus minus root 6, you are getting 0, which is not a irrational number. That means you cannot generalize it. The sum, difference, quotient and product, that is sum, difference, division and the multiplication of irrational numbers are not always irrational number. I have shown one addition here. So now you can take the difference. Suppose you take root 2 minus root 2. What is root 2 minus root 2 is also 0, which is also not an irrational number. Then you take root 3 into root 3. Root 3 into root 3 is 3. This is also not an irrational number. You take root of 5 by root of 5 division, it is 1, which is also not a irrational number. So you cannot say, suppose when you take root of 13 by root of 2, this is an irrational number. So therefore you cannot generalize the difference, sum, multiply and the division of irrational numbers are not always irrational. Now you take a rational number and irrational number. So when we add or multiply a rational number with an irrational number, we get an irrational number. So for example 2. 2 is a rational number. You add 2 plus root 3. So it is an irrational number. You take 2, multiply with an irrational number root 3. That is 2 root 3. It is also an irrational number. So therefore, when you add or multiply a rational number with an irrational number, we get an irrational number. Okay, so what you have learned today, first one, the sum or difference of a rational number with an irrational number is irrational. See, sum and the difference of a rational number, and that means if you take 2 minus root 3, that is a difference. That is also an irrational number. So 2 plus root 3 root 2, 2 minus root 3, all these are irrational numbers. The next one, second one, the product and quotient. Product or quotient of a non-zero rational number with an irrational number is irrational. Non-zero rational number you have to mention, because when you take 0, 0 is also a rational number. When you take 0 and take an irrational number root 3, 0 into root 3 will become 0. That is not an irrational number. Therefore, except 0, you take any rational number and then an irrational number, take the product or quotient. So suppose I take a rational number 2, irrational number root 2. So 2 into root 2 is 2 root 2. It is an irrational number. And take 2. Then take another irrational number root 3, divide. This is also an irrational number. Now third one, if you add, subtract, multiply or divide two irrational numbers, the result may be rational or irrational. Result may be rational or irrational. So two irrationals, when you take it, so I have shown you that root 3 and plus minus root 3. Root 3 plus minus root 3 is 0. So 0 is not a rational, 0 is a rational number. So see, suppose root 3 plus minus root 3 equal to 0. It is coming as a rational number. Suppose you take 2 root 3 plus 1 root 3, it is 4 root 3. So it is an irrational number. So that means it may be rational or irrational. Same in the case of subtraction, multiplication or division. Now, so the next one, so how to represent two root 3 plus root 3 is not 4 root 3, sorry, it is 2 plus 1 is 3 root 3. 3 root 3 is irrational number. How to represent, next one, how to represent root 10 for any positive integer n on the number line. You have learned root 2, root 3, root 5, etc. how to represent it on the number line, and you know how to mark the rational numbers are also on the number line. So now generally we are going to learn root 10. Root 10 is any positive integer. N is any positive integer. How to represent this one on the number line. So suppose, or you can say that find root x where x is any positive real number geometrically. That means we are how to represent this root x on the number line geometrically. So suppose I am taking x as 3.5. X as 3.5. So I am going to show root of the 3.5, mark root of 3.5 geometrically on the number line. So first what I should do is, I'll do the step-by-step explanation. First you draw a line AB of 3.5 units. 3.5 unit. Suppose you are taking centimeter as 1 unit, you take 3.5. Suppose you are taking 0.5 as 1 unit, then point into 5. So you have to you can fix the unit by yourself. So 3.5 unit you mark. So that is our AB. Then extend this one more unit to C. So therefore this is AB is our 3-point unit and this BC is our 1 centimeter. Then you have to find out the perpendicular bisector of AB. Perpendicular bisector of AB. That means you have to find out the midpoint of AC. AB ne AC. Midpoint of AC. That means you take your compass, more than half of AC you take like this, then draw an arc this side and this side, and same way from here you mark this side and this side, then you draw a just dotted line. So this dotted line is meeting here. This point is our midpoint O. This is our midpoint O. So this midpoint has center like this. You draw a semicircle which will pass through A and C. So it is you are just drawing a semicircle which is passing which is passing through A and C. You have to use your compass and do it. I don't have the compass with me, that's what I am showing it like this. After drawing the semicircle, you draw a perpendicular at B. So you know how to draw a perpendicular. You use your compass with B as center. You cut an arc on both the side. Otherwise, then from here you draw, from this point you draw an arc up, and from this point also you draw an arc like this. So then you draw a line from B. This is the perpendicular and this is BD. BD is perpendicular to AC at B. And this one is root of 3.5. This BD is the root of 3.5. Okay, so I'm just going to explain how you are getting this root of this BD as root of 3.5. Same, you have to draw AB. AB I am taking it as our X. This one you extend up to C. This is 1. Then you have to find out the midpoint O. Then draw the semicircle with a perpendicular as you have shown it. Then you draw a perpendicular at D, BD. Consider this right angle triangle BOD. Consider this by right angle triangle BOD. You know this distance AB is, okay, we have taken as 3.5. This is X. X is from A to B and BC is 1. So I am going to show, see what is this AC? AC is equal to X plus 1. Then OA is the midpoint, O is the midpoint, OA is the radius, OC is the radius, and OD is the radius. So OA is equal to, OD is equal to OC. So OA is equal to, OD is equal to OC. AC is x plus 1. So this is x plus 1 by 2. So OD is equal to x plus 1 by 2. Now you have to find out what, this is a right angle triangle because we have made this as a 90 degree. So in right triangle OBD, then this OA has become x plus 1 by 2. Now you need to find out OB. So OB means, you know, AB is x. So AB minus OA. AB minus OA, you will get OB. AB is x plus 1 by 2. OA is, what is OA? OA, you can say this is OA is equal to x plus 1 by 2. This OB is equal to OC minus 1. This is OC. OB is equal to, you can write down OC minus BC. See, OB is equal to OC minus BC. What is this OC? OC is equal to x plus 1 by 2. This OC is equal to x plus 1 by 2. Then this BC is 1. So x plus 1 minus 2 by 2, that is x plus 1 minus 1 is minus 1 by 2. So OB is equal to x minus 1 by 2. So now you have to come this BD. What is this BD? BD squared is OD squared minus OB squared. So what is OD squared? OD is x plus 1 by 2 the whole square. OB is x minus 1 by 2 the whole square. So this is x squared plus 2x plus 1 by 2 minus x squared minus 2x plus 1 by 2, 4. Then 4 as LCM. This is x squared plus 2x plus 1 minus x squared plus 2x minus 1. Because this minus will be applicable for all these three terms. So x squared cancel, plus 1 minus 1 cancel. It is 4x by 4, that is equal to x. Suppose you have taken as 3.5 here, this BD will become, this is x. But BD squared is equal to x, then BD is equal to root x. So if you take this this one AB as x or AB as 3.5, BD will be root of 3.5. If you are taking BD as 7.4, this AB as 7.4, this BD will become root of 7.4. Then how to represent this root of 3.5 on the number line? So this line BC you have to extend. You consider this B as the 0 of the number line. Number line we are drawing, this B you consider as this 0 and C as this C as 1 unit. Now you take this your compass and you put this at O as center, OD as radius. You draw an arc like this. BD should be equal to this point P. So P is root x. P represent root of x9, here it is 3.5. See, this B to C is 1 unit. What is this BP? Length BP is root of 3.5. The point P represent root of 3.5. You take B as center, BD as radius. You draw an arc and extend this line so that it will meet at P, that is a root of 3.5. So you have learned how to represent a real number geometrically on the number line.